Welcome back to the Energy Sovereignty Project and another quick topic. The quick topic today is brought to us by one of our subscribers, Prabdeep Dhaliwal. And he had a very interesting question that while I was trying to power up the studio for the morning, I tried to answer it about 3 times, and then I realized that it really was nuanced to the point where a typed out reply wasn't really going to cut it. So I decided to go ahead and do this as a quick topic. So I'll pull up his question here. So he asked about a company that Tesla had purchased a while back called Maxwell Technologies. Now, Maxwell Technologies, they developed ultracapacitors and also some battery technology that Tesla wound up purchasing. And the reason that the answer to his question is nuanced is that I think that Tesla purchased this company as much for their advancements in battery manufacturing as they did for the ultracapacitors themselves. So to start off real quick, let's talk just a little bit about capacitors and architecture and nomenclature of capacitors, just to kind of bring folks up to speed if they're not familiar about this whole thing. So a capacitor is a small component. Usually you see it in a lot of consumer electronics, and what it's designed to do is to smooth out power flow. It can take in a charge relatively quickly, and it can discharge that amount of energy very quickly, very rapidly. Now, capacitors can be quite large as well. They may look a little bit like a battery, but they store energy very different from a battery. Now, a battery stores energy usually in a chemical form, where a chemical change actually winds up storing the charge, whereas a capacitor actually stores that charge as a matter of its structure, as a matter of its architecture, just how it's made inside. Now, whereas a battery stores energy through a chemical transformation within it, it also has to discharge its power by reversing that chemical transformation. Now, a capacitor stores energy in exactly the same way and discharges its energy in exactly the same way as you discharge an energy into a doorknob after shuffling your feet across the carpet. All right? So both of these technologies, batteries and capacitors, they have their place. And what's going on now with ultracapacitors is that these components are now blurring the lines between what is a battery and what is a capacitor. So let's go ahead and talk a little bit about nomenclature. So again, we discussed the capacitor. Capacitor is a component that's able to take a charge relatively quickly and discharge it extremely quickly. But when it comes to storage, once a capacitor is fully charged, it discharges fairly rapidly over time. In other words, not like a battery. You would look at a capacitor discharging itself nearly completely within a matter of 10 or 15 minutes. Now, a supercapacitor is a capacitor that will charge more quickly than a standard capacitor and will store that charge for longer than a normal capacitor. That's it. That's all that we're getting at with that nomenclature when you start calling one thing one and one thing another. Ultracapacitors, that's a bit of a game changer. Once we get into ultracapacitors, the nomenclature is basically the same. It's just better at being a capacitor. So ultracapacitors, though they still charge, now they charge very rapidly. They discharge like a capacitor very rapidly, but they now do something that only batteries used to be able to do, and that is that they will hold a charge, and they will hold a charge for a much longer period of time. And again, now blurring that line between what is a battery and what is a capacitor. So Why don't we just make the entire battery pack out of capacitors, or out of ultracapacitors then? Well, the capacitor does still have an issue, and that is in its architecture, in the way that it stores that energy. Now, there are companies that are investigating using carbon nanotubes and all kinds of other technologies to increase the amount of power that it holds, and eventually that may actually lead to an entire battery being composed of ultracapacitors. But we're not there yet. And we're not there yet because of the fact that they are still fairly large for the amount of power that they're able to hold. How much they're able to hold by volume, that's going to be an interesting thing to see. That I can't answer with any great certainty, other than to say that they're getting better with each passing year. So let's talk about their application for a vehicle just briefly before we go into answering Pradip's question. So in vehicle technology, it's really easy to see why Tesla was after ultracapacitors. If you combine a, say, 100 kilowatt hour battery pack with, say, 20% of the capacity being ultracapacitors, and then the remaining 80% being standard lithium-ion batteries, then what you're able to do then is you've got a situation where roughly 70 miles of that overall range of the car can be replenished in that vehicle in less time than it would take to put the gasoline equivalent into a regular car to go 70 miles. And if all you're after is going 70 miles, well, now you've got a car that is very, very convenient, just as convenient as any gasoline vehicle. And that's really what electric vehicles are up against at this point, is the convenience factor. If we don't have a vehicle that can be refueled, as it were, as quickly as a gasoline vehicle, then it's just going to be an uphill slog. Same thing with the range. If we don't have a vehicle that's got the range of a petrol-powered car, then adoption is going to be pretty rough. So from Tesla's vehicle standpoint, that makes a lot of sense then to go after a company that can assist the battery technology in the vehicles with ultracapacitors, by allowing them access to everything that an ultracapacitor does well, and using eventually perhaps solid state battery technology. Now, I've said before that the only way that the math works with the Roadster 2.0 is if Tesla has weaponized a solid state battery. Well, the other things that you're able to do, if in fact you are able to reduce by half or so the volume of a battery by making it a solid state battery, now again you can make a greater portion of that battery contain ultracapacitors. So that means that you're able to charge the vehicle much, much faster, and as soon as you're done discharging, as soon as you remove that charging port, before you're actually even able to get into the vehicle, that ultracapacitor is already discharging and charging your main battery. And again, the main battery is there to hold a charge for a long period of time, days, a week or more, whereas the ultracapacitors are really only there to be able to hold that charge for a day, several hours a day, maybe 2 days. I don't know how good they've gotten them, right? But the battery is there for the long-term storage. Now, the other thing that the ultracapacitors do, remember we said that they charge and discharge very quickly. So as soon as you're done with the charge, you don't have to rely on a cold battery to be able to get 100% of the performance out of your car. And that's why I think it's going to be very important to the Roadster 2.0 and the Model S moving forward, especially as they start to examine maybe making the Roadster 2.0 be able to do track driving. The things that are very difficult on the vehicle are both the acceleration and the deceleration. When you decelerate and you use the the regenerative braking to charge the battery. If the battery is too full, it'll reduce the amount of regenerative braking. If the battery is cold, it will reduce the amount of regenerative braking. If the battery is overheated, it will reduce the amount of regenerative braking. All of these things are difficulties that batteries have that ultracapacitors don't. Because the ultracapacitor doesn't rely on a chemical change to charge or discharge, it also doesn't have the same issues with building up heat when it's charged or discharged. It's able to do so with much less thermal management. There still needs to be some, because not so much because of the ultracapacitor itself, but because you're discharging that and charging it through a wire, through a line, right? And that line may actually need some thermal management. We'll have to see how that progresses. Now, I'm sure by this point it's like, oh, what's he blathering on about? His question was about the Powerwall batteries. So the issue with the Maxwell acquisition has as much to do with the vehicle technology as it does with just the general battery technologies that will eventually trickle on down to the home. But like I said, it's nuanced. And so if you want to take a direct comparison between the home batteries and the vehicle, then the advantages that the ultracapacitors are immediately going to impart to the Powerwalls of whatever next generation we see is that the Energy Sovereignty Project, as you see it presented to you, is only possible because we're using 6 Powerwalls. I don't think we could do it with 4, much less 2 or 3. Right? Now, the reason for that doesn't have as much to do with the overall capacity of the Powerwalls themselves as it does to do with the fact that we're limited to a 5 kilowatt discharge from any given Powerwall. And so in order to handle a large home, you're going to need 3 of them to even have any hope of maintaining the current all of the time. All right? And if you have an electric vehicle, especially 2, heaven forbid that you're going to try and charge both of the vehicles at the same time, you just don't have the current outflow to be able to play that game. Well, the ultracapacitors, they do. So currently, if you are going to try and emulate what the Energy Sovereignty Project does, you're going to need at least 3 batteries. And even then, you're going to run into those times where briefly you'll have them not be able to supply all the power to the home. If you're trying to run an off-grid situation, certainly that can be a disaster because they may trip. We'll do some experiments with our batteries later on this year to find out exactly how they react under those types of situations, so we can kind of give you some more hard information on it. But certainly the 12 seconds that they supply may not be enough for kicking on AC systems while your dryer's going and that type of an application. And I said 12 seconds. The reason I said that is that under normal conditions, the Powerwall will supply 5 kilowatts, right? Each Powerwall will up their game to 7 kilowatts of output, but they'll only do it briefly, only for about 12 seconds. Well, if we add ultracapacitors to some degree along with the batteries that we have on the Powerwalls, now we're able to fully discharge. So for a period of maybe 5 or 8 minutes, again, depending on how much of your overall capacity of that Powerwall 3, let's go ahead and call it that, is composed of ultracapacitors, you'll be able to then extend that amount of time that you can draw very heavy loads off of the Powerwall and still be able to maintain the home loads. So what does that mean in the short term? Well, in the short term, again, to answer Pradeep's question, what that means then is that you'll be able to do what the Energy Sovereignty Project is doing with maybe 1 or 2 Powerwalls. And as the energy density also increases as they move towards solid state battery technology perhaps, then you'll be looking at perhaps a single Powerwall that will actually be able to have 30 kilowatt hours of total discharge capacity. All right? And so even in a fairly large home, you may be looking at only needing 1 or 2 power walls at the larger capacity. So we'll see. So short term, that's Prabdeep's answer. Now here's the nuanced part that I just really wasn't able to type out. So the information that I've just given you, there's probably a lot of YouTube channels that you could go to find that information, maybe even more in depth than the way that I've just given it to you. But the reason that you're here is because you want to get my take as an industrial process engineer on what is going to happen. All right? Well, there's another reason why Tesla purchased Maxwell Technologies. And that has to do with something that Maxwell Technologies discovered while they were making their ultracapacitors, while they were designing them. So current lithium-ion battery technology relies on a process where, again, hopefully not, I won't get hammered too much for oversimplifying this, but basically what you do is you create a paint. And it's a wet process by which you take the components of the battery, you make a paint out of it, and you spray that paint on a foil, which is then wound into the battery. Well, Maxwell Technologies discovered how to make a battery in what they call a dry process. Now, here's why that's so important. Maxwell Technology had the good sense to patent that technology. So Tesla purchased Maxwell not just for their ultracapacitor technology, but they also purchased it because now they have a patent on a technology by which they can use to make batteries. So let's talk about Panasonic for a minute. Tesla doesn't actually make batteries. Panasonic makes batteries. Panasonic makes batteries at the Gigafactory. Now, at the Gigafactory, there is a line through which Panasonic owns the footprint, and then Tesla receives the batteries from that section. Now, it is true that there are patents that are held by Tesla, and that there are intellectual property agreements between Tesla and Panasonic, so that Panasonic has a proprietary chemistry that they use for making Tesla's batteries. Now, this chemistry is very low in cobalt. That was one of the things that Elon Musk wanted to reduce. It's an expensive rare earth element, and sometimes there's some pretty nasty practices that go on as far as its mining, so we won't get into that. But the chemistry is unique to Tesla's batteries, but the process is not. Well, Elon Musk, very early on, as soon as the gates opened and he hit the ground running with development of Tesla as a automobile manufacturer, he knew that he was simply not going to survive unless he incorporated something called vertical integration. Now, vertical integration, from a manufacturing standpoint, is where the object you manufacture and sell is composed of components that you also manufacture and sell. Now, I will argue the point with anyone that Tesla, as we know it today, would not exist if they were not vertically integrated. If Tesla had to rely on getting, say, some component for its seats from a manufacturer that also gave seat components to Ford, GM, Toyota, that ultimately what would happen is that those companies would leverage their huge contracts with that seat manufacturer to make sure that they got seats before Tesla did. And from a car standpoint, if you don't have all the components to make your car, you're not making a car. You're not going to send that car out. That car may wind up in the parking lot while for 2 weeks you make cars that don't have seats. Then if you can imagine the nightmare of trying to take the seats out or bring the cars in so that you can put the seats back in. All the while you're still trying to make vehicles. Now, Tesla would never have survived something like that. So they knew that they were going to have to vertically integrate. And the one thing that they sure as hell knew was that they were going to have to vertically integrate their battery technology. Well, they built a facility by which Panasonic could make a whole bunch of batteries. And I'm not privy to what all of those contracts were, but Panasonic is making the batteries. That's not vertical integration. That's a point where Tesla is now going to have to figure out what they're going to do about that. And the last very nuanced part to answering Prabdeep's question is that what we're going to see, the benefit that we're going to see in 6 months, a year, 2 years from now in the Powerwall batteries will be the result of that trickle down from Tesla being able to now manufacture their own batteries, because now they will have intellectual property and patents that they can use to then take what they've learned from Panasonic and now actually start to, for the first time, actually manufacture their own batteries. And these batteries are going to be quite good. Elon Musk is no stranger to ultracapacitors. When he was at Stanford, his undergraduate work was all on ultracapacitors. And so while he may not have been following Maxwell Technologies specifically as a company, when he did finally go to examine Maxwell Technologies, it was not a case of him being led around by the nose by the technology or winding up buying into some company that produced vaporware. He knew exactly why he purchased Maxwell Technologies. It had something, perhaps many things, that he was looking to leverage on into the future. So Prabdeep, thank you very much for your question, and I hope that answered it sufficiently for you without making this an hour-long video. And for those who are just joining us, feel free to like and subscribe if this is the kind of information that you're interested in getting. And for those that have been following us, thank you very much, and we will see you shortly while I prepare the end of the month video for May, and we'll see you soon.